Hi everyone, welcome back. In this lesson, we are doing 10 worked examples on radicals. And 1, and 2, and 3. We will simplify radicals, convert mixed and entire radicals, add, subtract, multiply, divide, rationalize, and solve radical equations. If this helps, please like the video and subscribe to the channel. Example 1. Simplify square root 108. Start by looking for the largest perfect square factor. 108 is 36 times 3. Square root 36 is 6, so square root 108 simplifies to 6 square root 3. Example 2. Simplify cube root negative 54. Since this is a cube root, we look for a perfect cube factor. Negative 54 is negative 27 times 2. Cube root negative 27 is negative 3. So the answer is negative 3 cube root 2. Example 3. Convert 4 square root 5 into an entire radical. The number outside is 4. Move it inside by squaring it. For square root 5 becomes square root of 4 squared times 5. That is square root of 16 times 5, which is square root 80. Example 4. Add 3 square root 12 plus 2 square root 27. First simplify each radical. Square root 12 is 2 square root 3, so 3 square root 12 becomes 6 square root 3. Square root 27 is 3 square root 3, so 2 square root 27 becomes 6 square root 3. Add them to get 12 square root 3. Example 5. Subtract 5 square root 50 minus 2 square root 8. Simplify first. Square root 50 is 5 square root 2, so 5 square root 50 becomes 25 square root 2. Square root 8 is 2 square root 2, so 2 square root 8 becomes 4 square root 2. Subtract the coefficients and get 21 square root 2. Example 6. Multiply 2 square root 3 times 5 square root 6. Multiply outside numbers first. 2 times 5 is 10. Multiply inside numbers. 3 times 6 is 18. So we get 10 square root 18. Square root 18 simplifies to 3 square root 2. The final answer is 30 square root 2. Example 7. Divide 6 square root 75 by 3 square root 3. First divide the outside numbers. 6 divided by 3 is 2. Then divide inside the radicals. 75 divided by 3 is 25. So we have 2 square root 25. Square root 25 is 5, so the answer is 10. Example 8. Rationalize 7 over square root 5. We do not want a radical in the denominator. Multiply the numerator and denominator by square root 5. The numerator becomes 7 square root 5. The denominator becomes 5. So the final answer is 7 square root 5 over 5. Example 9. Solve square root of x plus 1 equals 5. The radical is already isolated. Square both sides. We get x plus 1 equals 25. Subtract 1, so x equals 24. Check it. Square root of 24 plus 1 is square root 25, which is 5. Example 10. Solve square root of x plus 4 equals x minus 2. First notice the right side must be non-negative, so x must be at least 2. Square both sides. We get x plus 4 equals x minus 2 squared. Expand to get x plus 4 equals x squared minus 4x plus 4. Move everything to one side. X squared minus 5x equals 0. Factor to get x times x minus 5 equals 0. So x equals 0 or x equals 5. Check the restrictions and the original equation. X equals 0 is extraneous and x equals 5 works. Great work! The big radical routine is this. Simplify first, use perfect square or perfect cube factors. Combine only like radicals, rationalize denominators when needed. And for equations, isolate, square, solve, and always check. Like the video and subscribe for more Math 20-1 worked examples.